In 1956, a French geographer named Henri Lehout set out from the town of Janet in southeastern Algeria with a team of local Tuareg guides, a handful of European assistants, and enough supplies for several months in the open desert. They were heading for a plateau called the Tassili, a vast sandstone shelf that rises out of the central Sahara like the ruins of some ancient city, cut through with canyons and overhangs and thousands upon thousands of rock shelters. Lotte had been there before, briefly, in the 1930s, and what he had seen on those rock walls had stayed with him for 2 decades. Paintings, thousands of them, herds of cattle in ochre and white, human figures dancing, swimming, hunting, scenes of daily life so vivid and so crowded with detail that they looked like they belonged to a world nothing like the one surrounding them. A world of water and grassland and abundance, painted onto rock that now stood in one of the driest places on Earth. He had come back to document as many of them as he could, and over the course of 16 months, his team copied more than 800 individual images, working in heat that cracked their paints and warped their paper. When those copies were eventually exhibited in Paris, they caused a sensation. But the sensation, as it often does, ran ahead of the science. One particular figure, a large round-headed shape that Lotte somewhat carelessly nicknamed the Great Martian God, caught the popular imagination in exactly the wrong way, and for years afterward, the Tassili paintings became tangled up with speculation about ancient visitors from space, which is a shame, because the real story, the one the evidence actually tells, is far stranger and far more interesting than any of that. What the Sahara hides is not aliens. It is not a lost civilization in the way that phrase usually gets used, not a single buried city waiting to be found. What it hides is something more diffuse and, honestly, more unsettling to the tidy version of the past that most of us carry around. It is the remains of an entire green world, a Sahara that was wet, that had rivers and lakes and monsoon rains, that supported fishing communities and cattle herders and people who built stone settlements and carved elaborate art and buried their dead with care across a stretch of time that lasted several thousand years. And then, relatively quickly, it all ended. The rain stopped, the lakes shrank, the rivers vanished, the people moved or adapted or disappeared from the record in ways we still cannot fully trace, and the desert came in and covered almost everything. The phrase that researchers use is the African Humid Period, sometimes called the Green Sahara, and it refers to a span running roughly from about 11,700 years ago to about 5,500 years ago, though both of those endpoints are argued over, and the transition at the end was almost certainly not a single clean event. During that window, the entire Saharan belt, an area roughly the size of the continental United States, received enough rainfall to sustain lakes, wetlands, and savanna-like vegetation across regions that today receive almost no rain at all. We know this from multiple independent lines of evidence, and the story of how we know it is genuinely one of the more fascinating detective stories in earth science. So settle in with this one. It is a long, slow, winding story, and it touches geology and archaeology and climate science, and even a little orbital mechanics, and it is full of real people doing real field work in genuinely difficult conditions. There is no rush. Let's start with the lakes, because the lakes are the thing that changed the conversation. If you look at a satellite image of the Eastern Sahara today, particularly the region of northern Chad, you can see something odd. There are pale, flat depressions in the landscape, some of them enormous, rimmed with what look like old shorelines. The largest of these is a basin called the Bodele Depression, which sits at roughly 160 meters above sea level and is one of the lowest points in the Sahara. Today, it is one of the single dustiest places on the planet. NASA instruments have tracked plumes of dust rising from the Baudelaire and crossing the Atlantic Ocean to fertilize the Amazon rainforest, which is a remarkable thing in itself. But the dust is made largely of diatomite, the fossilized remains of tiny freshwater organisms called diatoms, and that tells you something important. That dust is the powdered residue of a lake, a very large, very old lake. The lake is called Mega-Chad, or sometimes Paleo Lake, Mega-Chad, and at its greatest extent, probably around 6,000 years ago, it covered an area of roughly 360,000 square kilometers. For comparison, that is larger than the Caspian Sea today, which makes it one of the largest freshwater bodies that has existed anywhere on Earth in the recent geological past. The evidence for its size comes from multiple sources. Satellite radar, particularly data from the Space Shuttle Radar Topography mission in 2000, revealed ancient shoreline features buried under thin layers of sand across northern Chad and into Niger and Nigeria. Sediment cores pulled from the Baudelaire Depression contain layers of lacustrine, meaning lake-deposited, sediments alternating with layers of wind-blown sand, which gives you a record of the lake filling and emptying over time. And the diatom species preserved in those sediments are freshwater species, not the kind that tolerate salt, which tells you the lake was fed by substantial and sustained river inflow rather than just by local rainfall pooling in a basin. Here's the thing about Mega-Chad, though. It was not alone. Across the Sahara, during the African Humid Period, there were lakes everywhere. Lake deposits have been identified in Libya, in southern Egypt, in northern Sudan, in Mali, in Mauritania. Some of these were substantial bodies of water. Others were smaller, seasonal, more like the pans and playas you see in semi-arid landscapes today. But taken together, they paint a picture of a hydrological system that is almost unrecognizable compared to the modern Sahara. Rivers flowed where there are now sand seas. Groundwater tables sat close to the surface. Vegetation held the soil together and fed moisture back into the atmosphere through transpiration, which in turn helped sustain the rainfall. It was a feedback loop, and understanding how that loop started, how it maintained itself, and how it eventually collapsed is one of the central questions in Saharan paleoclimatology. The starting mechanism, at least in broad terms, is reasonably well understood, and it involves something that sounds almost comically large-scale for a story about rain in Africa. It involves the tilt of the Earth's axis and the shape of the Earth's orbit around the Sun. These are called the Milankovitch cycles, after the Serbian mathematician Milutin Milankovic, who worked out the basic theory in the early 20th century. The key cycle here is precession, which is the slow wobble of the Earth's rotational axis over a period of roughly 26,000 years. What precession does, among other things, is change when in the Earth's orbit, the northern hemisphere is tilted most directly toward the Sun. Around 11,000 years ago, the northern hemisphere's closest approach to the Sun, called perihelion, fell during the northern hemisphere summer rather than during winter as it does today. The practical effect of this was to increase the amount of solar energy hitting North Africa during summer by something in the range of 7 to 8% compared to present values. That does not sound like much, but it was enough to strengthen the West African monsoon system dramatically, pulling the rain belt hundreds of kilometers farther north than it reaches today, deep into what is now the Sahara. That orbital forcing is the trigger. But here is where it gets genuinely interesting, and where the science is still very much alive and contested. The orbital change alone, when you plug it into climate models, does not produce enough rainfall to explain the lakes. The models consistently underestimate the amount of moisture that the Sahara received during the African Humid Period. This is sometimes called the Green Sahara problem in climate modeling, and it has been a persistent headache since the 1990s. The gap between what the orbital forcing predicts and what the geological evidence shows has to be filled by feedbacks, by processes that amplified the initial push. Vegetation feedback is one of the leading candidates. As rain increased, plants spread northward. Plants have darker surfaces than bare sand, so they absorb more sunlight and warm the surface, which strengthens the thermal. Low-pressure systems that pull in moist air from the Atlantic. Plants also transpire, releasing water vapor back into the atmosphere, which provides additional moisture for rainfall. So more rain means more plants, which means more rain, which means more plants. It is a positive feedback loop, and in principle, it can amplify a modest orbital push into a dramatic climate shift. But even vegetation feedback, when added to the models, still tends to fall short. Some researchers have argued that changes in dust emission matter too. A vegetated Sahara produces far less dust than a bare one, and dust in the atmosphere affects cloud formation and radiation balance in complex ways. Others have pointed to the role of lakes and wetlands themselves as moisture sources, essentially arguing that the lakes helped sustain the rainfall that sustained the lakes. And a group led by the climate scientist Peter Domenical at what was then the Lamont Doherty Earth Observatory has emphasized the role of ocean surface temperatures in the tropical Atlantic, which affect how much moisture the monsoon can carry inland. The honest summary is that no single model has yet reproduced the full magnitude of the Green Sahara using only known physical processes, and the reasons for that shortfall are still being actively investigated. What makes this more than just a modeling puzzle is the question of how the Green Sahara ended. Because the ending, it turns out, may have been sudden, and that word, sudden, in a geological context, carries a lot of weight. The orbital forcing that initiated the humid period was gradual. Precession is a slow cycle. The tilt of the Earth's axis did not snap back into position over a decade or a century. It drifted smoothly over thousands of years. So you might expect the drying of the Sahara to have been equally gradual, a slow retreat of the rain belt, a gentle expansion of the desert margins, lakes shrinking century by century. And some of the evidence does suggest a gradual transition. Pollen records from certain lake cores show a slow shift from grassland species to desert-adapted species over a span of 1,000 years or more. But other records tell a very different story. Marine sediment cores from the Atlantic Ocean floor off the coast of West Africa contain layers of wind-blown dust that were carried out to sea from the continent. In a landmark 1999 paper, Domenical and his colleagues showed that the dust flux in these cores increased abruptly around 5,500 years ago, shifting from low values consistent with a vegetated landscape to high values consistent with open desert in what appeared to be a matter of centuries, possibly less. The transition in the marine record looked less like a gentle fade and more like a switch being flipped. That finding opened a question that researchers are still working on today, and it connects to something much larger than the Sahara itself. If a slow, gradual change in orbital forcing can produce a rapid, abrupt climate shift through the collapse of feedback loops, then what does that tell us about how climate systems behave in general? The Green Sahara may be one of the clearest examples in the geological record of a climate tipping point, a threshold beyond which a system flips from one stable state to another without passing smoothly through the middle. And the people who lived through that transition, the herders and fishers and hunters whose traces are scattered across the desert in rock art and stone tools and buried settlements, they experienced something that we are only now beginning to understand through the tools of modern climate science. They experienced the end of a world. Now, saying it that way sounds dramatic, and I want to be careful here, because the reality was probably more complicated and more human than any single phrase can capture. What we know about the people who inhabited the Sahara during its green phase comes from a patchwork of evidence, and like most patchworks, it has gaps, frayed edges, and places where the stitching doesn't quite hold. But the picture that emerges is genuinely remarkable, and it's worth spending some time with. Let's start with what the landscape actually looked like during the peak of the humid period, say around 8,000 years ago. You've already heard about Mega-Chad, that enormous body of water covering an area larger than the modern Caspian Sea. But Mega-Chad wasn't alone. Across the Sahara, there were hundreds of lakes, some of them substantial. Lake Ptolemy, in what is now the Fezzan region of southwestern Libya, covered thousands of square kilometers. Paleolac Gobero, in the Tenere Desert of Niger, was smaller but left behind one of the most extraordinary archaeological sites ever found in the Sahara. The rivers were real too. Radar imaging from space, particularly from the shuttle imaging radar missions in the 1980s, revealed ancient river channels buried under meters of sand in Egypt and Sudan, channels that once carried water across landscapes that today receive essentially no rainfall at all. Some of these channels were enormous, comparable in width to the modern Nile. So picture that. Not a uniform grassland, not a single ecosystem, but a mosaic. Savannas with scattered trees in some areas, denser woodland near rivers and lake margins, marshes and wetlands where water pooled, open grassland on higher ground, and yes, probably patches of drier terrain too. The Sahara during the humid period was not the Amazon. It was more like parts of modern East Africa. The Sahel pushed north by 1,000 kilometers or more, with all the ecological variety that implies: crocodiles, hippos, elephants, giraffes, large fish. All of these are attested in the rock art and in the faunal remains found at archaeological sites. The rock art at Tassili, Niger, the paintings that Henri Lot and his team spent those 16 months copying, depict cattle herds, human figures swimming, canoes, and scenes of daily life that make no sense at all in the context of the modern desert, but make perfect sense if you understand what that landscape used to be. And people were everywhere. This is one of the things that sometimes gets lost in discussions of the Green Sahara, the sheer density of human occupation. Archaeological surveys across the region have documented thousands of sites, from small seasonal camps to larger, more permanent settlements. In the Caucasus Mountains of Libya, not far from Tassili, Italian-led excavations beginning in the 1950s and continuing for decades under the direction of Fabrizio Mori uncovered rock shelters with deep stratigraphic sequences showing occupation stretching back more than 10,000 years. At Ouan Muhugiag, one of the most famous of these shelters, researchers found evidence of a community that processed wild grains, herded cattle, and made sophisticated pottery. They also found a carefully prepared child burial, dating to roughly 5,500 years ago, wrapped in animal skin and preserved by the dry conditions. The care taken with that burial tells you something about the people involved, about the weight they gave to loss. But it's the site at Gobero, in Niger, that really brought the human story of the Green Sahara into sharp focus. Gobero was discovered in 2000 by Paul Sereno, a paleontologist from the University of Chicago who was actually in the Tenere looking for dinosaur fossils. His team stumbled across human bones eroding out of the sand dunes near the edge of what had once been a lake. When they returned in 2005 for systematic excavation, what they found was extraordinary. 200 burials spanning roughly 5,000 years, from about 10,000 to 5,000 years ago, belonging to two distinct populations separated by a gap of about 1,000 years. The earlier group, associated with a culture called the Kiphian, were tall, robust people, some of the males standing over 6 feet, who hunted large game and fished in the lake. Their pottery and tools were distinctive. The later group, associated with the Tenerian culture, were smaller, more gracile, and their material culture was different. They herded cattle, used different tool types, and their burials included remarkable grave goods. One burial, perhaps the most famous from the site, contained 3 individuals, an adult woman and 2 children, laid together on a bed of flowers, their limbs intertwined, with pollen analysis confirming the presence of the flower petals beneath them. That burial dates to about 5,300 years ago. Think about what that means for a second. Someone, 5,300 years ago, in the middle of what is now one of the most inhospitable deserts on Earth, gathered flowers and laid them down as a bed for the dead. That's not a data point. That's a human act, as legible now as it was then. The gap between the Kiphian and Tenerian occupations at Gobero is itself significant. It corresponds to a period of increased aridity around 8,000 years ago, a dry spell within the broader humid period that apparently made the area uninhabitable for roughly a millennium before conditions improved again, and a new population moved in. This tells you that the Green Sahara was not a single, stable paradise. It flickered. There were dry intervals within the wet period, times when lakes shrank and people had to move, and then wetter returns when the landscape recovered and people came back. The climate was dynamic, and the people living in it had to be dynamic too. Which brings us to something important about how these communities actually worked. The dominant picture that has emerged over the last few decades, built from the work of dozens of research teams across multiple countries, is one of mobility and adaptation. During the peak humid period, many Saharan communities appear to have been semi-nomadic pastoralists, people who kept herds of cattle and moved with them across the landscape in response to seasonal shifts in water and grazing. The rock art supports this. So do the settlement patterns, which tend to cluster around former lake margins and river channels, but show the kind of light, repeated occupation you'd expect from people who came and went rather than staying put year-round. Pottery styles and raw materials for stone tools sometimes show up hundreds of kilometers from where they were made, suggesting networks of movement and exchange that spanned enormous distances. Here's the thing, though. We know far less about these communities than we should, and the reasons for that gap are worth understanding because they shape everything else about this story. The Sahara is enormous. It covers roughly 9 million square kilometers, an area about the size of the entire United States. Archaeological survey coverage across that area is wildly uneven. Some regions, like the Caucasus Mountains, Tassili, and parts of the Nile Valley, have been studied intensively for decades. Others, vast stretches of Libya, Chad, southern Algeria, and northern Mali, have barely been surveyed at all. Political instability has played a role. Libya's archaeological heritage, which is extraordinary, became largely inaccessible to international research teams after 2011. Northern Mali and parts of Niger have been affected by conflict for years. Chad has never had the kind of sustained foreign-funded archaeological presence that Egypt or even Sudan has enjoyed. And then there's the simple, logistical challenge of working in a place where summer temperatures routinely exceed 50 degrees Celsius. Water has to be trucked in, and the nearest hospital might be a 2-day drive away. Fieldwork in the deep Sahara is expensive, physically punishing, and sometimes dangerous. And the funding bodies that support archaeological research have historically preferred to invest in places that are easier to reach and already well documented. The result is that our picture of the Green Sahara's human inhabitants is built from islands of intensive study, surrounded by an ocean of terra incognita. We know a great deal about certain sites and almost nothing about the spaces between them, and those spaces are enormous. When you hear someone say that the Sahara still hides something, this is a big part of what they mean. Not that there's a single lost city waiting to be found, though who knows, but that the fundamental baseline of knowledge, the simple question of who lived where and when, remains profoundly incomplete for most of the region. And that incompleteness matters enormously when you try to answer the question that Domenical's dust flux data raised so sharply. What happened to these people when the rain stopped? Where did they go? How fast did they have to move? The traditional assumption, held for a long time, was that the desiccation of the Sahara pushed populations toward the Nile Valley, and that this migration contributed to the rise of pharaonic civilization in Egypt. It's a tidy story, and there may be elements of truth in it, but the evidence is far more complicated than the story suggests. For one thing, the timing doesn't line up as neatly as you'd want. The most rapid phase of Saharan desiccation, as recorded in Domenical's marine cores and in terrestrial records from lake sediments across the region, appears to have occurred between about 5,500 and 4,000 years ago. But the earliest stages of what would become Egyptian civilization, the pre-dynastic cultures of the Nile Valley, were already developing before 5,500 years ago. The Badarian culture, one of the earliest pre-dynastic groups in Upper Egypt, dates to roughly 4,500 to 4,000 BC, which overlaps with but doesn't follow the main aridification pulse. And the Nile Valley itself had its own long history of occupation that didn't require Saharan refugees to explain it. Still, there are tantalizing connections. Cattle iconography in early Egyptian culture, certain pottery traditions, particular burial practices, these have parallels in Saharan pastoral traditions that are hard to dismiss as coincidence. Rudolf Cooper, a German archaeologist who spent decades working in the Egyptian Western Desert, proposed a model he called the Saharan pump, in which the Sahara alternately drew populations in during wet periods and pushed them out during dry ones, with the Nile Valley serving as a kind of refugium during arid phases. It's an elegant model, and it accounts for a lot of the archaeological evidence, but testing it properly requires exactly the kind of comprehensive survey data that the Sahara, by its very nature, makes almost impossible to gather. And that's worth sitting with for a moment, because it's one of those problems that sounds simple, but turns out to be structural. Something built into the landscape itself, rather than a failure of effort or imagination. Think about what archaeological survey means in practice. In a place like southern England or the Nile Delta, you can walk a transect, a straight line across a field, picking up every potsherd and flint flake you see on the surface, and over a few seasons you build a picture of where people were living, how densely and roughly when. You can do this because the land is accessible, because farmers turn the soil and bring material to the surface, because the distances involved are manageable, and because there's a long institutional tradition of people doing exactly this kind of work. Now try to imagine doing the same thing across 9 million square kilometers of sand, rock, and gravel, much of it without roads, some of it without reliable water sources, a significant portion of it inside countries where fieldwork permits are difficult to obtain or where active conflict makes the question academic. The Sahara is roughly the size of the United States. The archaeological coverage, even after a century of intermittent work, amounts to tiny islands of knowledge in an ocean of nothing. Cooper himself estimated that the explored portion of the Egyptian Western Desert, one of the better studied parts of the Sahara, represented a vanishingly small fraction of the total area. And the Egyptian Western Desert is comparatively easy to work in, flat, politically stable for long stretches, close to established research infrastructure in Cairo and the Nile Valley. Go further west, into Libya, Chad, southern Algeria, northern Mali, and the picture thins out dramatically. So when we talk about testing models like the Saharan pump, we're really talking about a future that depends on tools and circumstances that don't fully exist yet. And this is where the story takes a turn that I find genuinely fascinating, because the tools that have moved the needle most in the last couple of decades aren't trowels and transect lines. They're satellites and algorithms and techniques borrowed from fields that have nothing to do with archaeology. You already know about the shuttle imaging radar missions from the early 1980s, the ones that revealed buried river channels beneath the sand. That was a proof of concept, a demonstration that remote sensing could see things in the Sahara that no human on the ground ever would. But the technology has moved enormously since then. Modern synthetic aperture radar, carried on satellites like the European Space Agency's Sentinel-1 constellation, can image the surface and near surface of the desert at resolutions that would have seemed absurd in 1982. Optical satellite imagery, from platforms like Landsat and the commercial providers that followed, gives you the ability to scan vast areas for the kinds of surface signatures that indicate buried features, slight discolorations in the sand, faint geometric patterns, changes in vegetation that trace underground moisture. And then there's the revolution in multispectral and hyperspectral imaging, which reads the landscape in wavelengths of light the human eye can't see, picking up mineral signatures and moisture content that map beautifully onto ancient lake margins and river courses. Here's the thing. These tools don't find archaeological sites directly. What they find are landscapes, the ghosts of environments that once supported life. A paleo lake shoreline shows up as a faint arc of slightly different sediment chemistry. A buried river channel shows up as a linear anomaly in radar returns. And where you find ancient water, you find the places where people would have lived. It's inference, not detection, but it's powerful inference, and it's the only way anyone is ever going to build a regional picture of human occupation across an area this size. One of the most striking examples of this approach came from work in the Libyan Fezzan, the inland desert region south of Tripoli. A team led by David Mattingly, a British archaeologist based at the University of Leicester, used satellite imagery combined with ground survey to map an extraordinary network of settlements, irrigation channels, and fortified farms built by the Garamantes, a Saharan civilization that flourished from roughly the first millennium BC into the first millennium AD. Now, the Garamantes are much later than the Green Sahara period we've been talking about. They're an Iron Age and Classical Era society, but the methodology Mattingly's team developed is directly relevant. They showed that you could use freely available satellite data to identify sites across hundreds of square kilometers of desert, then target ground survey to confirm and date what the satellites had found. The efficiency gain was enormous. Instead of walking every meter of a landscape that would take lifetimes to cover on foot, you let the satellite do the first pass and send people to the places that look most promising. And this matters for the deeper past, too, because similar techniques have been applied to the detection of Holocene lake deposits and associated archaeological material. Work by teams using radar and optical data has identified hundreds of previously unknown paleo-lake basins across the eastern Sahara, many of them in areas that have never been visited by archaeologists. Each one of those basins is, in principle, a place where people gathered, fished, herded cattle, made tools, and left traces. The material is out there. The question is whether anyone will ever get to it, which brings us back to a problem that isn't technological at all. It's political and practical. The Sahara spans roughly a dozen countries, and the conditions for archaeological fieldwork vary wildly among them. Egypt has a well-established antiquities infrastructure, though permits for foreign teams can be difficult, and the focus has historically been overwhelmingly on pharaonic and later periods rather than deep prehistory. Algeria has produced some of the most important rock art sites in the world, Tassili chief among them, but access has been complicated at various times by internal security concerns. Libya, which contains some of the richest and least explored prehistoric landscapes in the entire Sahara, has been effectively closed to systematic fieldwork since the collapse of the Gaddafi government in 2011. The Fezzan work I just mentioned, Mattingly's Garamantes project, was interrupted by the conflict and has only partially resumed. Chad, home to the Baudelaire Depression and to Paleolake shorelines of extraordinary scale, has limited archaeological infrastructure and persistent security challenges in its northern regions. Niger, where Paul Sereno found Gobero, faces similar constraints. Mali, northern Mauritania, western Sudan, these are places where the archaeological potential is immense, and the practical obstacles are, for the moment, close to insurmountable. So you end up with a situation that's genuinely unusual in modern science. The data exists, in the sense that the sites are out there, the material is preserved in the dry conditions, the satellite imagery is available, and the analytical techniques are ready. But the human infrastructure, to connect those things, the teams on the ground, the permits, the funding, the political stability, the institutional will, that infrastructure is fragile and unevenly distributed. And this isn't a new problem. It's the same problem that has shaped Saharan archaeology from the beginning, the reason why Lahote's Tassili expedition in 1956 was such a sensation. He went to a place almost nobody had been and found something extraordinary, and the implication was obvious. If this is what one expedition found in one corner of the desert, what else is out there? That question has never been answered, and the honest reason is that the Sahara is simply too big, too difficult, and too politically fragmented for the kind of systematic work that would be needed. The explored fraction remains tiny. Every few years, someone finds something remarkable. A new rock art site, a new burial ground, a new paleolake with stone tools scattered along its ancient shore, and each discovery reinforces the same uncomfortable truth. We are drawing conclusions about a vast, complex, long-inhabited landscape based on a handful of keyhole views. Now, there's one more dimension to this that deserves attention, because it connects the remote sensing work back to the climate question we talked about earlier. Remember the Green Sahara problem. The fact that climate models consistently underestimate the amount of rainfall the Sahara received during the African Humid Period. One of the reasons models struggle is that they need accurate boundary conditions. They need to know where the lakes were, how big they were, how much of the surface was vegetated, in order to calculate the feedback loops correctly. And that information comes from exactly the kind of landscape mapping that satellite remote sensing provides. So there's a beautiful circularity here. The same tools that help archaeologists find sites also help climate scientists calibrate their models. And better models in turn help archaeologists understand what the landscape looked like when people were living on it. A particularly important contribution came from a study published in 2013 by a team including Christoph Schutt and others who used radar data to map a massive previously unrecognized river system beneath the sands of the Eastern Sahara. The channels they identified suggested a drainage network far more extensive than anyone had appreciated, one that would have carried seasonal or even perennial water across landscapes that are now among the driest on Earth. And here's what's interesting about that finding from an archaeological perspective. Those channels are corridors. They're the routes along which people and animals would have moved, the connective tissue of a landscape that we usually think of as empty. If you want to understand how populations shifted during the wet phases and the dry phases, how Cooper's pump actually worked in practice, those buried rivers are your map. But almost none of them have been ground-truthed. The satellite sees the channels. Nobody has walked along them picking up the tools and pottery and grinding stones that almost certainly line their banks. And this is where we are, really, suspended between what the technology can show us and what the ground can confirm. The Sahara keeps offering glimpses through radar returns and marine sediment cores and chance discoveries by paleontologists looking for dinosaur bones, and each glimpse suggests a world far more populated, far more connected, and far more dynamic than the empty dunes we picture today. And that gap between what we suspect and what we can prove is one of the defining frustrations of Saharan research. But it's also, in a quieter way, one of its most exciting features, because it means the next discovery could come from almost anywhere. Let's talk about one of the places where discoveries actually have come, and where they've come in a way that changed how people think about the whole question. We need to go back to the lake beds. Not Megachad this time, but a different set of ancient lakes, smaller ones, scattered across what is now the Libyan desert and the western desert of Egypt. These are the places where, if you know what to look for, you can still find traces of water on the surface. Not water itself, obviously, but the mineral deposits, the lacustrine sediments, the cracked playa surfaces that tell you water once pooled here, sometimes for centuries at a stretch. One of the most important of these sites is a place called Nabta Playa, and it sits about 100 kilometers west of Abu Simbel, deep in the Egyptian Western Desert. Today, it is spectacularly inhospitable. Summer temperatures regularly exceed 50 degrees Celsius. Rainfall is essentially zero. There is nothing there, in the conventional sense. No town, no road worth the name, no permanent habitation of any kind. And yet Nabta Playa contains one of the most remarkable concentrations of prehistoric activity found anywhere in the Sahara, and it was discovered, like so many things in this story, more or less by accident. In 1973, a team led by Fred Wendorf, an American archaeologist from Southern Methodist University in Dallas, was driving across the desert and stopped to camp. Wendorf had been working in the Nile Valley and the surrounding deserts for years, and he had a practiced eye. What he noticed at the campsite were stone artifacts and fragments of animal bone eroding out of the surface. That's all it took. He came back. He kept coming back, in fact, for the next 3 decades, through multiple field seasons, assembling a picture of Nabta Playa that grew more surprising with every campaign. What Wendorf and his collaborators, including the Polish archaeologist Romuald Schild, eventually documented was a site that had been occupied repeatedly over thousands of years, beginning around 11,000 years ago and continuing until roughly 5,500 years ago, when the rains failed for the last time and the playa dried up permanently. During the wet phases, The playa would fill seasonally, creating a shallow lake that attracted animals, and with them, people. The earliest occupations show small groups of hunter-gatherers using the lake margins, but over time, the evidence shifts. By about 9,000 years ago, there are deep storage pits, wells dug into the playa sediments to reach groundwater and, crucially, the bones of domesticated cattle. Now, this is a detail worth sitting with, because the dating of cattle domestication in Africa is one of those arguments that has been running for decades and still hasn't fully settled. The conventional view for a long time was that cattle domestication originated in the Near East, in the Fertile Crescent, and spread westward into Africa. But the Nabta Playa evidence, along with findings from a few other Saharan sites, suggested something more complicated. The cattle bones Wendorf's team recovered were early, very early, and the question of whether they represent independently domesticated African cattle or animals derived from Near Eastern stock that arrived via the Nile corridor is genuinely unresolved. The genetics have been studied, and there is evidence for at least some degree of independent African domestication of the wild aurochs, Bos primigenius, but the picture is messy. Different studies using different genetic markers have produced different answers, and the sample sizes from these ancient Saharan contexts are small. Here's the thing about Nabta Playa, though. The cattle are not even the most famous part. What really put the site on the map, and what generated the most debate, is a set of stone constructions that Wendorf's team began documenting in the 1990s. There are several components. There are tumuli, large stone-covered mounds, some of which contained the remains of cattle, carefully arranged. There are stone-lined hearths, and what appear to be ceremonial or ritual structures, and then there is the stone circle. The Nabta Playa stone circle is small. It's about 4 meters across. It consists of a ring of small, upright slabs, some of them barely knee-high, with a few taller stones set in pairs along what appear to be sight lines. Wendorf and a collaborator, the astrophysicist Kim Malville from the University of Colorado, proposed in the late 1990s that these alignments corresponded to the summer solstice and possibly to the rising points of certain stars, including those in the belt of Orion. The claim was that Nabta Playa represented one of the earliest known astronomical alignments in the world, predating Stonehenge by perhaps 2,000 years. And this is where you have to be careful, because claims about ancient astronomical alignments are among the most easily overstated in all of archaeology. The problem is a statistical one. If you have a set of stones, and you're free to draw lines between any pair of them, and you're free to check those lines against the rising or setting points of any star at any date over a range of several thousand years, you will find alignments. You will always find alignments. The question is whether those alignments are intentional or coincidental, and answering that question requires you to demonstrate that the number and precision of the alignments exceeds what you'd expect from chance alone. Malville and Wendorf argued that they did. Other researchers have been more cautious. The stones are small, some have shifted over the millennia, and the sample size is limited. But even setting the astronomical claims aside, what's not in dispute is that the people at Nabta Playa were doing something organized and deliberate with stone on a significant scale, and they were doing it at a remarkably early date. The tumuli alone are impressive. One of them, when excavated, was found to contain a large block of sandstone that had been shaped and placed in a pit, with the remains of a young cow arranged around it. The effort involved in quarrying, transporting, and placing that stone in a desert environment, without any of the logistical infrastructure we associate with later monument-building cultures, tells you something about the social organization of these people. They weren't just passing through. They were investing labor, coordinating effort, and marking the landscape in ways that were meant to endure. Vendorf argued, and others have echoed this, that Nabta Playa might represent a kind of ceremonial center for semi-nomadic pastoralist groups who ranged across a wide territory during the wet season and converged on the playa when it filled. Think of it as a gathering point, a place where different bands came together, perhaps annually, to water their cattle, to trade, to perform whatever rituals the tumuli and the stone arrangements represent. This interpretation fits nicely with what we know about pastoralist societies in other parts of Africa, where seasonal aggregation sites play exactly this kind of social and ceremonial role. And it fits with Cooper's model of the Saharan pump because it suggests a population that was mobile, flexible, and responsive to climatic shifts, moving with the rains rather than being pinned to one location. But here's what's interesting about Nabta Playa in the larger context of our story. The site's occupation ends right around 5,500 years ago. The same moment, give or take a few centuries, that Demenical's dust flux record shows the Sahara drying out. The same window during which the Tenarian people at Gobero, over 1,000 kilometers to the west, were laying their dead in the sand for the last time, and the same period during which the pre-dynastic cultures of the Nile Valley were beginning to coalesce into something that would eventually become Pharaonic Egypt. Vendorf himself suggested that the people who left Nabta Playa may have carried their traditions, their cattle-centered rituals, their astronomical knowledge, and their social structures eastward to the Nile, contributing to the cultural substrate from which Egyptian civilization emerged. It's a compelling idea. It's also very hard to test. The problem, as always, is the gap in the record. Between the last occupation at Nabta Playa and the earliest pre-dynastic sites in the Nile Valley, there are centuries of silence. The migration, if it happened, left no trail that anyone has yet been able to follow. You'd need a chain of sites, each a little closer to the Nile, each a little later in date, showing continuity in material culture, in burial practices, in the types of cattle being herded. That chain might exist. It might be buried under sand or under Nile alluvium or in parts of the desert that nobody has surveyed. But until someone finds it, the connection between Nabta Playa and early Egypt remains a hypothesis, not a demonstrated fact. And this brings us to something that hasn't been discussed enough yet, which is the sheer difficulty of doing archaeology in the Nile Valley itself. You might think the Nile corridor would be the best studied landscape in Africa, and in some ways it is. Egyptology has been a professional discipline for 2 centuries. But the pre-dynastic period, the millennia before the pharaohs, has always been the poor relation of the field. The spectacular tombs and temples of dynastic Egypt attracted the funding and the attention, while the earlier, less visually dramatic layers were often dug through hastily or ignored altogether. And there's a physical problem too. The Nile floods, or it did before the Aswan High Dam was completed in 1970, deposited meters of alluvial sediment across the valley floor every year for millennia. Pre-dynastic sites in the floodplain are buried deep. Some of them are below the modern water table, which means excavating them requires constant pumping and is ruinously expensive. Others were destroyed outright by the construction of the dam and the creation of Lake Nasser, which flooded a vast stretch of the Upper Nile Valley in the 1960s. There was a famous international rescue campaign, the UNESCO Nubian Salvage Campaign, which ran from 1960 to 1980 and managed to relocate the temples of Abu Simbel and document a number of threatened sites. But the campaign was focused on the monumental heritage, the things that could be seen and saved. the pre-dynastic layers beneath the floodplain, the ones that might have shown the arrival of Saharan pastoralists with their cattle and their stone circle traditions, were largely beyond reach. So the very corridor through which the Saharan exodus would have had to pass is the one place where the archaeological record is most compromised, which means that if you want to understand the relationship between the Green Sahara and the rise of complex societies along the Nile, you're working with a record that has holes in exactly the wrong places. You have the Saharan sites, Nabta Playa and Gobero, and a handful of others, showing sophisticated pastoralist communities that disappeared around 5,500 years ago. You have the early Nile Valley cultures, Badarian and Nakada, and their predecessors, showing the emergence of social stratification, long-distance trade, and eventually state formation. And in between, you have sand and silt, and the unexcavated space where the answer might be hiding. This is where a different kind of evidence has started to fill in some of the gaps, and it comes not from archaeology at all, but from genetics. Over the past decade or so, the field of ancient DNA has undergone what can only be described as a revolution, and that revolution has begun, cautiously, to reach into North Africa. The challenges are significant. DNA degrades faster in hot, arid environments than in cold or waterlogged ones, which means that extracting usable genetic material from Saharan or Nile Valley remains is far harder than doing the same work in, say, Scandinavia or the Andes. But the techniques have improved dramatically. Methods developed in the 2010s for recovering highly fragmented ancient DNA from petrous bones, the dense bone behind the ear, have opened up samples that would have been useless a decade earlier. And a few studies have begun to sketch, in very broad strokes, the genetic history of North African and Nile Valley populations. One of the most discussed was a 2017 study that extracted ancient DNA from Egyptian mummies, primarily from the site of Abu Sir el-Melek in Middle Egypt. The samples ranged from about 1500 BC to roughly 400 AD, so they're later than the period we're most interested in, but they offered a baseline. What the study found was that the ancient Egyptian samples showed strong genetic affinity with Near Eastern populations and relatively little sub-Saharan African admixture, at least in that particular time window and that particular site. The sub-Saharan component increased in more recent samples, suggesting gene flow from the south over the past 2,000 years. But here's what that study could not tell you, and what its authors were careful to point out. It could not speak to the pre-dynastic period. It could not speak to Upper Egypt or Nubia, where the Saharan connection would have been strongest. And it was based on a single site. The genetic map of ancient North Africa is still almost entirely blank for the periods and places that matter most to our question. There are ongoing efforts, teams working on older remains from different parts of the Nile Valley, but the results are slow in coming because the material is so degraded. And meanwhile, out in the desert itself, another line of evidence has been quietly accumulating, one that doesn't require human remains at all. It's called sedimentary ancient DNA, or cetDNA, and it works by extracting genetic material not from bones or teeth, but from the sediment itself, from the layers of dirt and sand and dried mud that, built up on ancient lake beds and in cave deposits over thousands of years, plants shed DNA into the soil, animals leave traces through dung and urine and decomposition, and under the right conditions, those traces survive, locked into the mineral matrix of the sediment, for thousands of years. By sampling a sediment core layer by layer, you can reconstruct the biological community that existed at that location at different points in time, without ever finding a single bone or seed. This technique is still young, and its application to Saharan contexts is in its earliest stages, but the potential is enormous, because it sidesteps the preservation problem that has always plagued Saharan archaeology. You don't need to find artifacts. You don't need to find burials. You just need a sediment column from a former lakebed, and the Sahara has thousands of those. The question is whether the DNA has survived in those specific sediments, and early results from a few test cases suggest that in some locations it has. If the technique scales, it could provide a continuous biological record of the Sahara's transformation from grassland to desert, including the presence and movement of domesticated species like cattle and goats, without a single excavation. So the tools are arriving, slowly, unevenly, and always constrained by funding and access, but they're arriving. And each one adds a new dimension to a picture that, even 15 years ago, was drawn almost entirely from stone tools and rock art and the occasional lucky find by someone who stopped their car in the right patch of desert. The question now is not whether the Sahara was once green and full of people. That much is settled. The question is something more specific and in some ways more difficult, and it has to do with what happened in between. Between the green and the dry. Between the lakes and the dust. Between the people who lived there and the people who showed up somewhere else, apparently already knowing things, already carrying traditions and technologies and ways of organizing society that don't seem to come from nowhere. That transition, the centuries or maybe millennia, during which the Sahara went from a place people lived to a place people fled, is the part of the story that remains genuinely unresolved, and it's the part that matters most if you want to understand how it connects to everything that came after. Think about it this way. We know, from the dust record off the coast of West Africa, from the pollen cores, from the lake sediment data, that the Sahara dried out. We know from the archaeological record that people were living across it in large numbers, with cattle and goats and elaborate ritual practices, right up until around 5,500 years ago. And we know that within a few centuries of that date, complex societies appear along the Nile, societies that eventually become what we call Pharaonic Egypt. The temptation is to draw a straight line. People leave the Sahara, walk east or north, arrive at the Nile, and build pyramids. Fred Wendorf suggested something like this for Nabta Playa. Others have proposed it more broadly, and the idea has a certain elegance to it, because the timing works, roughly, and the direction of movement makes geographic sense. But here's the thing. A straight line requires evidence at every point along it, and the evidence in the middle is almost entirely missing, not because it was looked for and not found, but because, for the most part, nobody has been able to look. The areas between the known Saharan sites and the Nile Valley are among the least archaeologically surveyed landscapes on Earth. Some of them are in active conflict zones. Some are in countries where foreign research permits are difficult or impossible to obtain. Some are simply so remote, so lacking in infrastructure, that mounting an expedition is a logistical problem on the scale of a small military operation. And the ones that have been surveyed, even partially, tend to raise more questions than they answer. Take the western desert of Egypt, the region between the oases and the Nile. This is the corridor through which any migration from places like Nabta Playa would logically have passed. And there are sites out there. Surface scatters of stone tools, the remains of temporary camps, the occasional hearth. But they're fragmentary, undated in most cases, and almost impossible to connect into a coherent sequence. The desert. Surface is a palimpsest. Thousands of years of human activity compressed into a single deflated layer, where a Neolithic blade might sit centimeters from a Paleolithic hand axe, with nothing to tell you which came first, except typology. And typology, the classification of tools by their shape and manufacturing technique, is a blunt instrument when you're trying to track a specific population moving through a landscape over a few centuries. It tells you someone was there. It doesn't tell you when, or where they came from, or where they went next. This is the problem that has haunted the migration hypothesis for decades. It's not that the idea is wrong. It might well be right, or partly right. It's that the kind of evidence you'd need to confirm it, a chain of dated sites showing a clear directional movement of people and their cultural practices from the interior Sahara toward the Nile, simply doesn't exist yet. And the reasons it doesn't exist are practical, not mysterious. They have to do with sand and politics and money and the fact that archaeology as a discipline has historically concentrated its resources on places where you can see things on the surface, and the relevant parts of the Sahara are places where the surface tells you almost nothing. So researchers have tried to come at the question from the other end. Instead of tracing people out of the Sahara, they've tried to look at what shows up in the Nile Valley and ask whether it has Saharan fingerprints. And this is where things get genuinely interesting and genuinely complicated. The pre-dynastic period in Egypt, roughly 6,000 to 5,100 years ago, is the stretch of time during which the communities along the Nile transitioned from scattered farming villages into something more politically organized, eventually coalescing into the unified state we call the Old Kingdom. The archaeology of this period is patchy, for the reasons we talked about earlier: the alluvial burial of sites, the Aswan Dam, the long bias toward dynastic monuments. But what does survive shows some intriguing patterns. Cattle play an outsized role in pre-dynastic symbolism and ritual. Cattle burials appear at sites like Hierakonpolis, one of the most important pre-dynastic centers in Upper Egypt, where a young cow was found buried with the same care given to human interments. Cattle imagery dominates early Egyptian cosmology in ways that persist right through the dynastic period. And the cattle themselves, the physical animals, appear to have been present in the Nile Valley earlier than the agricultural package that came from the Near East, the wheat and barley and sheep and goats that formed the basis of Egyptian farming. Now, if you remember the debate about cattle domestication at Nabta Playa, this is where it becomes relevant again. If cattle were independently domesticated in North Africa from local aurochs, as some of the Nabta Playa evidence suggests, then the prominence of cattle in early Nile Valley culture could reflect a tradition that came from the West, from the Saharan pastoral world, rather than from the Levantine farming tradition that arrived from the Northeast. That would be a genuine Saharan fingerprint. But the genetic evidence on cattle domestication is still contested. Some studies support an independent African domestication event. Others argue that all domestic cattle derive from a single Near Eastern domestication, and that what looks like local domestication in Africa is actually the early arrival of already domestic cattle from the East, which then interbred with local wild aurochs. The molecular clock estimates don't agree with each other. The sample sizes are small, and the oldest cattle bones from Nabta Playa, the ones that would settle the question, are fragmentary enough that different analysts have reached different conclusions from the same material. So even the cattle question, which sounds like it should be answerable with modern genetics, remains genuinely open. And it matters, because if you could prove that the Nile Valley's cattle tradition was Saharan in origin, you'd have the first solid link in the chain. Not proof of mass migration, necessarily, but proof of cultural transmission from the drying interior to the river valley. And cultural transmission implies contact, which implies movement, which starts to fill in that empty middle. There's another thread worth following here, and it has to do with stone. Structures. Not the megaliths of Nabta Playa, but something found much further west, in a part of the Sahara that gets even less attention. The Central and Western Sahara, particularly in what is now Algeria, Libya, Niger, and Chad, contains thousands of stone monuments that have never been systematically studied. We're talking about tumuli, stone circles, alignments, and elaborate funerary structures scattered across landscapes that are now utterly barren. Some of these were noted by French colonial officers in the 19th and early 20th centuries. A few were mapped. Fewer still were excavated, and those excavations were often hasty, poorly documented, and conducted with methods that would not pass review today. The material that was collected ended up in French museums, where much of it sat in storage for decades, poorly catalogued and largely forgotten. In the 1990s and 2000s, a few researchers began revisiting this material. One of the most significant efforts was led by a team working in the Tassili Niger region, the same area where Henri Lotte had copied those extraordinary rock paintings in the 1950s. They found that the stone monuments in the region spanned an enormous time range from the late Neolithic through to the historical period, and that some of the earliest ones, dating to around 5,000 to 4,500 years ago, showed construction techniques and spatial organization that didn't obviously derive from any known tradition. The stones were deliberately selected, transported from specific sources, and arranged according to principles that suggested planning and communal labor. Not on the scale of Stonehenge, nothing like that, but on a scale that implies social organization beyond the family group. And here's what's interesting about the timing. These monuments are being built right at the moment when the Sahara is drying out, right at the moment when the pastoral communities that had lived across this landscape for millennia are being squeezed, forced to concentrate around the remaining water sources, forced to make decisions about where to go and what to take with them. The monuments might be markers of territory, claims staked on shrinking resources. They might be memorials, ways of fixing identity to a place that people knew they were about to leave. They might be something else entirely. The honest answer is that we don't know, because the excavation record is so thin. What we do know is that they exist in numbers that are hard to grasp. A survey conducted using satellite imagery in 2009 across a section of southwestern Libya identified over 100,000 stone structures visible from space. 100,000. And that was one section of one country. The researchers who published the study, David Mattingly's team at the University of Leicester, the same group that had mapped the Garamantes sites before the Libyan conflict made fieldwork impossible, were careful to note that most of these structures had never been visited on the ground. Their dates were unknown. Their contents were unknown. Their relationship to each other was unknown. They were visible, countable, and almost completely uninterpreted. Think about what that means for a second. We have a region of the Earth's surface roughly the size of the continental United States, covered in the remains of human activity spanning thousands of years, and the vast majority of it has never been examined by a trained archaeologist. The structures are there. The rock art is there. The former lake beds with their sediment columns are there. The buried river channels mapped by radar are there. And almost none of it has been ground-truthed, dated, sampled, or excavated. The Sahara is not a blank in the human story because nothing happened there. It's a blank because the logistical, political, and financial barriers to working there have been, and remain, enormous. And this is where the story takes a turn that has less to do with ancient people and more to do with modern institutions. because the question of why the Sahara remains so poorly understood is not just a question about sand and distance. It's a question about how archaeology as a discipline allocates its attention, and that allocation has a history of its own. One shaped by colonialism, by Cold War politics, by the economics of academic publishing, and by the simple fact that some deserts are easier to get permits for than others. The story of what we don't know about the Sahara is inseparable from the story of who has been allowed to look and who has been told their work matters enough to fund. And that second part, the funding, is worth sitting with for a moment because it shapes the archaeological map of the Sahara more than any sandstorm ever has. Consider how a typical excavation gets paid for. A researcher at a university writes a grant proposal. That proposal goes to a funding body, a national research council, a private foundation, sometimes a government ministry of culture in the country where the site is located. The proposal is reviewed by other specialists, and those specialists ask reasonable questions. What is the site? What do you expect to find? What is the significance? And here's the thing. If you're proposing to excavate a well-documented site in the Nile Valley, you can answer those questions with confidence. You can cite 100 years of prior work. You can point to museum collections, published typologies, radiocarbon sequences, stratigraphic profiles. You can say, with evidence, that a season of digging at this particular spot will produce results that connect to an existing framework of knowledge. The reviewers nod. The money flows. But if you're proposing to investigate a cluster of stone structures in the Central Sahara that have never been visited on the ground, you can't answer those questions in the same way. You don't know what you'll find. You can't cite prior work because there is no prior work. You can't connect the results to an existing framework because the framework doesn't exist yet. And so the proposal is riskier, harder to justify, and less likely to be funded. The result is a feedback loop. Places that have been studied get studied more, because each new study generates the publications and the context that make the next study fundable. Places that have never been studied stay unstudied, because there's no existing body of work to anchor a new proposal to. It's not a conspiracy. It's just how institutional incentives work, and it has been working this way for a very long time. You can see the effect in the numbers. Egypt has entire government ministries devoted to antiquities, hundreds of active foreign missions, dedicated journals, annual conferences, a global tourism economy that creates its own pressure to keep digging. Sudan has far fewer missions, far less infrastructure, and a fraction of the attention, despite the fact that its Nile Valley archaeology is continuous with Egypt's and in some periods arguably richer. Move west into Libya, Chad, Niger, Mali, and the ratio drops further. Algeria has a handful of active projects, most of them focused on the well-known sites like Tassili Na'ajer, and for the vast interior, the Tenere, the Tanez-Ruft, the Libyan Sand Sea, the Tibesti, you're looking at a landscape where the last systematic archaeological survey might have been conducted in the 1970s or 80s, if one was conducted at all. The colonial legacy matters here in a specific and concrete way. During the French and Italian colonial periods in North and West Africa, archaeological work in the Sahara was often conducted by military officers, colonial administrators, or expedition-style explorers rather than by trained archaeologists working within a research framework. Henri Lot, whose Tassili expedition opened this whole story, was a self-taught ethnographer and explorer, not an academic archaeologist in the modern sense. His work was extraordinary, but it was also shaped by the priorities and assumptions of its era. The rock art was documented, sometimes beautifully, but the surrounding deposits were rarely excavated. The focus was on the spectacular, the painted panels, the dramatic shelters, not on the less photogenic, but scientifically crucial work of sampling sediments, dating hearths, analyzing faunal remains. When independence came to Algeria in 1962, to Libya in 1951, to Chad and Niger and Mali in 1960, the new governments inherited borders drawn by Europeans, economies structured around extraction, and archaeological records that were fragmentary, housed in foreign museums and published in French or Italian journals that local researchers often couldn't access. Building a national archaeology from that starting point, while also building roads and schools and hospitals, was not a trivial ask. And, in many cases, it simply didn't happen. Not because anyone decided the past didn't matter, but because the present was more urgent. Then there's the question of conflict. Libya's revolution in 2011 didn't just halt David Mattingly's Fazan project. It destabilized the entire permit and access system for a country that contains some of the richest and least explored archaeological landscapes on the planet. The Garamantes sites in the Fezan, the rock art of the Akakis, the stone monuments of the Mesak, all of these became effectively unreachable for foreign researchers, and they've remained difficult to access ever since. Chad has faced decades of intermittent conflict in its northern regions, precisely the areas where the most significant Saharan archaeology is likely to be found. Northern Mali, home to sites that satellite imagery suggests are extraordinarily rich, has been destabilized by insurgency since 2012. Niger's northern regions face similar security concerns. The pattern is consistent and grim. The places where the archaeology is most likely to rewrite our understanding of Saharan prehistory are, by and large, the places where it is most dangerous or most politically complicated to work. So what do you do when you can't get to the ground? You look from above. And this is where the story loops back to the remote sensing work we talked about earlier, but with a different emphasis now. Because what's happened in the last decade or so is that satellite archaeology has moved from being a supplement to fieldwork to being, in many parts of the Sahara, the only kind of archaeology that's possible. Researchers like Mattingly's team and others working with freely available satellite data have been able to identify, map, and classify tens of thousands of structures across regions that no archaeologist has ever walked. The resolution of commercial satellite imagery has improved dramatically. Where the early Landsat images of the 1970s and 80s could show you a lakebed or a major river channel, modern imagery from platforms like Worldview or Pleiades can resolve individual stone walls, burial cairns, even the outlines of collapsed shelters. Combine that with synthetic aperture radar, which can penetrate dry sand to reveal buried features, and you have a toolkit that is genuinely transformative. But here's where the honest limits come in, and they're important. A satellite image can tell you that a structure exists. It can tell you its shape, its dimensions, its spatial relationship to other structures. It can sometimes tell you, based on morphology and comparison with excavated examples elsewhere, roughly what category it might belong to. But it cannot tell you when it was built. It cannot tell you what's inside it. It cannot tell you whether the people who built it were pastoralists or farmers or hunter-gatherers. It cannot tell you what they ate, what language they spoke, what diseases they suffered from, how they organized their societies, or where they came from. All of those questions require someone to go there, to dig, to collect samples, to run analyses. Remote sensing is magnificent at generating questions. It is structurally incapable of answering them. And this creates a peculiar situation. We now have, thanks to satellite archaeology, a far more detailed picture of the Sahara's built landscape than anyone could have imagined even 20 years ago. We know roughly where the structures are. We know their density, their distribution, their clustering patterns. We can see that certain landscapes were intensively occupied and modified by human communities over what must have been long periods. But we cannot say much more than that, because the ground truthing that would turn those observations into historical knowledge has barely begun. It's a bit like having a library catalog that lists every book in the building, their titles and shelf locations, but being unable to open any of them. There are exceptions, and they matter. In the Mesak Setafet, a sandstone plateau in southwestern Libya, Italian and British teams managed to conduct some fieldwork before the conflict, and what they found was striking. The plateau is covered in rock art, thousands of engravings depicting wild animals, cattle, human figures, hunting scenes, and more abstract designs. But the surrounding landscape also contains stone structures, grinding surfaces, hearths, and lithic scatters that suggest sustained occupation over millennia. Some of the engravings depict animals that haven't lived in the region for thousands of years: large crocodiles, hippopotami, giraffes, elephants, which gives you a rough terminus antiquem, a not later than date, based on when those species disappeared from the area. But rough is the operative word. Without direct dating of the engravings themselves, which is technically very difficult for petroglyphs, the chronology remains fuzzy. And that fuzziness is the recurring theme. Across the Sahara, from the Tassili to the Tibesti, to the Gilf Kabir, we have a vast archive of human expression and activity that we can see but cannot precisely date, cannot securely connect to specific populations or economic systems, and cannot integrate into the broader narrative of African prehistory in the way that Nile Valley material has been integrated. The archive is there. The tools to read it are, in principle, available. What's missing is the sustained, funded, permitted, logistically supported fieldwork that would begin to turn visibility into understanding. And yet, there are people trying. In the last few years, a handful of projects have found ways to work in or around the barriers. Some have partnered with local institutions in Saharan nations, building capacity and sharing data in ways that earlier generations of researchers rarely did. Others have focused on the Saharan margins, the Sahel, the northern edges of the desert in Tunisia and Morocco, where access is easier, and the transitional zones between green and dry may hold exactly the kind of intermediate evidence that the big narrative needs. Still others have turned to museum collections, revisiting material excavated decades ago with modern analytical techniques. Bones collected by Wendorf's team at Nabta Playa in the 1970s, for instance, have been reanalyzed using techniques that didn't exist when they were first dug up: ancient DNA extraction, stable isotope analysis, high-resolution CT scanning. Each reanalysis adds a layer of information to material that was already in a drawer, waiting. And then there's the sediment record, which doesn't require anyone to find a site at all. Paleoclimate researchers have been pulling cores from lake beds, from ocean margins, from dry playas across the Saharan belt, and those cores contain pollen, phytoliths, diatoms, charcoal fragments, and other proxies that tell you what the landscape looked like at a given time, even if no human artifact is present. The charcoal is particularly interesting because spikes in charcoal deposition can indicate burning, and burning in a grassland or savanna context can be natural, or it can be anthropogenic, deliberately set by people managing the landscape. Distinguishing between the two is difficult, but when you see charcoal spikes that correlate with the appearance of pastoral indicators elsewhere in the record, the suggestion of human landscape management becomes hard to dismiss. This is the kind of evidence that might, eventually, fill in the gap between the Green Sahara and the Nile Valley. Not a single dramatic discovery, not a lost city or a buried library, but the slow accumulation of proxy data from dozens of cores, hundreds of radiocarbon dates, thousands of satellite-mapped structures, gradually stitched together into something that starts to resemble a picture. It's painstaking work, and it doesn't make headlines the way a pharaoh's tomb does, but it's the work that is actually moving the needle. And it moves slowly, not in leaps, but in this quiet, patient way that doesn't announce itself. Think about what a single sediment core actually gives you. Someone drills into a dry lakebed, maybe in northern Chad, maybe on the margin of the Tenere, and they pull up a cylinder of compressed earth that might be 2 or 3 meters long. That cylinder is a timeline. Each layer corresponds to a period when something was happening on the surface above, rain falling, plants growing, fires burning, dust blowing in from somewhere else. And the researchers who work with these cores aren't reading them the way you'd read a book, top to bottom with a clear narrative. They're reading them the way you'd read a very old, very damaged letter, where half the words are smudged and the pages are out of order. Every proxy, every pollen grain, or phytolith, or charcoal fragment tells you one narrow thing about one narrow aspect of the environment at one narrow moment. The skill is in layering those narrow things on top of each other until they start to cohere. And here's what's clever about the way this work has developed over the last couple of decades. The cores themselves aren't new. People have been pulling sediment cores out of the Saharan belt since the 1960s. What's new is the resolution. Modern techniques can slice a core into intervals as fine as a centimeter or less, and each of those slices can be dated independently using radiocarbon on organic material or optically stimulated luminescence on the sediment grains themselves. So instead of saying this layer is roughly mid-Holocene, you can say this layer dates to approximately 5,200 years before present, give or take a century. That precision matters enormously when you're trying to correlate what's happening in one core from Chad with another core from a marine sediment column off the coast of Mauritania, with archaeological dates from Nabta Playa 1,500 kilometers to the east. The whole game is correlation. Can you line up events across space and see whether they're simultaneous or sequential or completely unrelated? And this is where the picture gets genuinely interesting, because some of the correlations that have emerged in the last 10 or 15 years are suggestive in ways that nobody quite predicted. Take the charcoal record. Several cores from the central Saharan belt show distinct spikes in microcharcoal concentration during the period between about 7,000 and 5,000 years before present. Now, that period overlaps with what we know was the peak and early decline of the African Humid Period, the time when pastoralist groups were most active across the region. The question is whether those charcoal spikes represent natural wildfire in a drying grassland, which would make perfect sense climatically, or whether they represent deliberate burning by pastoral communities managing grazing land. which would make perfect sense ethnographically, because controlled burning to encourage fresh grass growth is one of the oldest and most widespread pastoral practices on the planet. The honest answer is that the charcoal alone can't tell you. A burned grass fragment looks the same under a microscope, whether lightning started the fire or a herder did. But when you combine the charcoal data with pollen records from the same cores showing shifts in grass species composition, particularly toward species that respond well to burning, and when you see those shifts happening in areas where satellite imagery has identified stone pastoral enclosures on the surface, the circumstantial case for anthropogenic landscape management starts to build. Nobody has proven it yet. That's worth being clear about. What exists right now is a pattern, not a proof. But the pattern is consistent across multiple independent lines of evidence, and it points towards something that would be genuinely significant if confirmed, which is that the people living in the Green Sahara weren't just passively inhabiting a favorable environment. They were actively shaping it. They were burning grasslands to manage forage, possibly selecting for certain grass species, possibly altering the vegetation structure of entire regions. And if that's true, then the transition from the Green Sahara to the Nile Valley isn't just a story about climate refugees fleeing a drying landscape. It's a story about skilled landscape managers carrying a sophisticated set of ecological practices with them into a new environment. That's a very different kind of migration, and it would have very different implications for how we understand the origins of agriculture and settlement along the Nile. Now, this is speculative. I want to be honest about that. The data points in this direction, but the data is sparse, and the interpretive leaps required are significant. The researchers working on this, people like Katharina Neumann, who has spent decades studying the archaeobotany of the Saharan belt, are careful to frame their findings as hypotheses rather than conclusions, and they're right to be careful, because the alternative explanation, that the charcoal and vegetation shifts are purely climatic responses to increasing aridity, is perfectly viable and doesn't require you to invoke human agency at all. The landscape was drying. Fires would have become more frequent naturally. Grass species, adapted to drier conditions, would have expanded. You don't need people in the picture to explain what the cores show. You just might want them there, because the fit with the archaeological record is suggestive. And this is the kind of tension that makes the Sahara such a fascinating problem right now. The evidence is always almost enough to confirm human landscape management, almost enough to trace a migration route from the central Sahara to the Nile, almost enough to link Nabta Playa's astronomical alignments and cattle ceremonialism to the earliest expressions of Egyptian religion. Almost, but not quite, because the intermediate steps are missing. And the intermediate steps are missing because they're buried under sand in places where nobody can safely work, or they were never preserved in the first place because the preservation conditions in a tropical grassland are terrible compared to the hyper-arid desert that replaced it. Wood rots, leather rots, bone survives poorly in acidic soils. The very environment that supported these communities was the environment least likely to preserve evidence of them. So you end up in this strange situation where the driest, most inhospitable parts of the Sahara, the places that were uninhabitable during the humid period, are actually the places where evidence is best preserved today, because extreme aridity is the best preservative there is. Ouan Mahugiag, that rock shelter in the Akakis Mountains of southwestern Libya, where the child mummy was found, survived precisely because the shelter dried out completely as the climate shifted. The mummy, the animal skins, the plant material, all of it was preserved by the same aridity that made the place unlivable. Meanwhile, the lake shores where people actually spent most of their time, the places where communities gathered, where cattle were herded, where the real density of human activity would have been, those places went through cycles of wet and dry that destroyed organic material systematically. What survives there is stone. Stone tools, stone circles, stone tumuli. And stone, as we've talked about, is almost impossible to date directly. This is the preservation paradox that haunts Saharan archaeology. The center of the story is the hardest place to find evidence, and the margins of the story, the rock shelters and desert edges, are where the evidence clusters. It's like trying to understand a city by studying only its suburbs. You can learn a lot, but you're always aware that the main event is somewhere else, somewhere you can't quite reach. Which brings us to what might actually break the impasse, and it's not a technology or a technique so much as a shift in how the problem is framed. For decades, the question has been posed as a binary. Did the people of the Green Sahara migrate to the Nile Valley and contribute to the rise of Egyptian civilization, or didn't they? Wendorf thought yes. Many Egyptologists have been skeptical, in part because the material culture doesn't show obvious continuity, and in part because the Nile Valley had its own long indigenous development that doesn't need an external catalyst to explain it. But increasingly, researchers are suggesting that the binary itself is the problem. Migration doesn't have to mean a single dramatic exodus. It doesn't have to mean one group arriving in one place and founding one civilization. It can mean, and in most documented cases throughout history it does mean, a slow, multi-generational process of movement, mixing, adoption, and adaptation spread across centuries and involving countless small groups, making countless small decisions about where to go next as conditions shifted. If that's what happened, and the climate data strongly suggests that the drying of the Sahara was not a single event, but a stuttering, regionally variable process that played out over more than 1,000 years, then you wouldn't expect to find a single migration route or a single cultural signature moving from point A to point B. You'd expect to find exactly what the record actually shows, which is a complicated, patchy, inconsistent scatter of similarities and differences across a vast area, with some elements that look Saharan showing up in the Nile Valley and others that don't, with timing that varies from place to place, with local traditions persisting alongside imported ones. The messiness of the record isn't a failure of the evidence. It might be the evidence. It might be telling you exactly what happened, which was something far more complex and far more human than a neat arrow on a map. And this reframing matters because it changes what you're looking for. If you're looking for a lost city, you need to find a lost city, and if you don't find one, you failed. But if you're looking for a pattern of slow diffusion across a drying landscape, then every new radiocarbon date, every reanalyzed bone, every charcoal spike in a sediment core, every satellite-mapped stone enclosure is a data point that either supports or complicates the pattern. You don't need a single dramatic discovery. You need 1,000 small ones. And that's exactly what's happening right now, slowly, across dozens of disciplines and hundreds of sites and thousands of individual researchers, most of whom will never make a headline, but whose work, taken together, is gradually filling in one of the largest blank spaces on the map of human history. Think about what the last 2 decades have actually produced. Not a single revelation, not a Tutankhamun moment, but a steady accumulation of small, unglamorous findings that, when you lay them side by side, start to form something. A team in Chad pulls a sediment core from a dried lake bed and finds that the local environment was still wet enough for cattle grazing 300 years after the regional climate models say it should have been desert. That matters because it means the people living there had more time than anyone assumed, more time to adapt, more time to develop new strategies, more time to move or to stay. A graduate student in Berlin reanalyzes pottery sherds from a 1970s Libyan excavation that had been sitting in a museum drawer for 40 years, runs residue analysis on the interior surfaces, and finds traces of fermented dairy. Not just milk. Fermented milk, which tells you something specific about processing knowledge and about gut biology and about how long these communities had been living with cattle. A French-Algerian collaboration uses high-resolution satellite imagery to map over 100 previously unrecorded stone tumuli in a single river valley in the Hoggar Mountains, structures that nobody had walked up to and measured, let alone excavated, but that now exist on a map, with coordinates, with rough dimensions, waiting. None of these findings, on their own, settles anything. The Chad core doesn't prove migration. The dairy residue doesn't prove domestication origin. The tumuli don't prove anything at all yet, because nobody has opened them. But each one is a constraint. Each one narrows the range of stories you can tell about what happened in this landscape and still be consistent with the physical evidence. And that narrowing is the work. That's how it actually happens in archaeology. Not through a single golden discovery, but through the patient, unglamorous process of ruling things out, one data point at a time, until the remaining possibilities start to converge. Here's the thing about the Sahara specifically, though. The convergence is still a long way off. And the reason it's a long way off isn't because the evidence doesn't exist. It's because the evidence is scattered across an area roughly the size of the continental United States, buried under sand, or locked in rock shelters, or sitting in museum collections on 3 different continents, catalogued in French and Arabic and Italian and English, published in journals that don't always cite each other, gathered by teams that sometimes don't know the other teams exist. The problem isn't a lack of data. The problem is integration. It's synthesis. It's getting all of these small findings into the same room, metaphorically speaking, and asking what they look like together. And there are people trying to do exactly that. The Trans-Sahara Project, which has been running in various forms since the early 2000s, is one attempt to build a framework that connects climate data, archaeological survey, and satellite remote sensing across national boundaries. It's slow work, and it's limited by all the constraints we've already talked about: funding, access, politics, the sheer physical difficulty of working in one of the most inhospitable environments on Earth. But it exists, and it's producing results, and the results are consistently surprising in the same direction, which is that there was more going on in the Green Sahara than anyone's models predicted. More people, more complexity, more connection between regions, more sophisticated responses to environmental change. Stefan Kröppelin, the German geologist who has spent decades working in the Eastern Sahara, particularly in the Unyanga Lakes region of northern Chad, has been one of the voices arguing most persistently that the transition from wet to dry was not the catastrophe it's sometimes painted as. His lake cores, some of which preserve continuous records going back tens of thousands of years, show a landscape that dried in stages, with periods of partial recovery, with microenvironments that stayed viable long after the surrounding terrain had turned to sand. The Unyanga lakes themselves are still there, fed by fossil groundwater, remnants of a hydrological system that was once vastly larger. Kroppelin's argument, and it's a careful one grounded in decades of fieldwork, is that the people living through the aridification were not passive victims of climate change. They were active agents who adapted, who shifted their subsistence strategies, who moved when they needed to and stayed when they could, who managed water and vegetation in ways that the archaeological record is only beginning to reveal. And this connects to something broader that's been developing across the environmental sciences over the past 15 or 20 years, which is a growing recognition that human beings have been shaping their environments far longer and far more profoundly than the old models assumed. The idea that pre-agricultural or early pastoral societies simply lived within their ecosystems, taking what nature offered without significantly altering it, has been challenged by evidence from every inhabited continent. The charcoal spikes and fire-responsive grasses we talked about earlier, the ones Katharina Neumann has been tracking in West African pollen records, are part of this larger picture. Whether or not those fires were deliberately set, and the evidence is genuinely ambiguous, they point to a landscape that was being shaped by human presence in ways that would have been invisible to a casual observer. But that show up clearly in the sediment record thousands of years later. So what would it actually take to resolve the big questions? Not all of them, that's unrealistic, but the central ones. The ones that have been hanging over this story since Henri Lot knelt in front of those painted rock faces in Tassili, Niger, in 1956, and wondered who had made them and where they had gone. The honest answer is that you'd need three things, and none of them is impossible, but none of them is easy either. First, you'd need systematic excavation of a handful of key sites in the deep Sahara, the ones that satellite imagery has identified, but nobody has reached. Not hundreds of sites, even 5 or 6, carefully chosen, properly excavated, fully published, would transform the picture. A single well-stratified site in the central Sahara with organic preservation, datable material, and evidence of subsistence practice would do more to constrain the models than another decade of remote sensing. The technology to find these sites exists. The technology to excavate them exists. What's missing is access, funding, and in many cases, security. Second, you'd need a serious, coordinated ancient DNA program focused on the Saharan and Saharan-adjacent populations. The work that's been done so far, on individuals from Gobero, on scattered remains from the Nile Valley, on a handful of North African sites, has been tantalizing but fragmentary. A comprehensive study, one that could map genetic relationships across the entire region through time, would settle some of the migration questions that have been debated for decades. The analytical tools exist. The statistical frameworks exist. What's needed is a large enough sample from a wide enough geographic and temporal range, and that means more excavation, which brings you back to the first problem. Third, you'd need better climate models, ones that can reproduce the African Humid Period accurately at regional scales. The current generation of models, as we discussed, consistently underestimates the rainfall that the proxy data says was there. Until the models can match the data, the models can't be used to predict where people could and couldn't have lived, which means the archaeological predictions that flow from those models are unreliable. This is a problem in atmospheric physics and ocean-atmosphere coupling, and it's being worked on. But it's genuinely hard, and it may require a better understanding of vegetation feedbacks, the way that plant cover itself changes rainfall patterns, which loops back into the question of whether humans were altering the vegetation, which loops back into the charcoal record, which loops back into the need for more and better sediment cores. Everything connects. Everything depends on everything else. And maybe that's the most honest thing to say about the Sahara, and the something it still hides, the something that nobody has quite been able to name. It isn't a single thing. It isn't a lost civilization or a buried city or a forgotten empire. It's a process, a vast, slow, deeply human process of living in a landscape that was changing under people's feet, adapting to that change in ways both brilliant and desperate, and eventually moving on, carrying with them knowledge and practices and beliefs that filtered into the cultures that came after, in the Nile Valley and across the Sahel and into West Africa, and perhaps further, in ways that are genuinely difficult to trace because the evidence is sparse and scattered and ambiguous, and because the desert itself, the great preserver and the great destroyer, has kept some things and erased others according to its own indifferent logic. The rock art is still there, in Tassili and the Akakas and the Enedi, and 100 other shelters scattered across the central highlands. The cattle still run across those walls, painted by hands that understood their animals with an intimacy that comes only from generations of close dependence. The swimmers still swim in their vanished lake. The figures still gather, still dance, still do things that no one alive can confidently interpret. And beneath the sand, beneath the gravel plains and the dry river channels and the eroded plateaus, the record waits. Fragmentary, difficult, often maddeningly incomplete, but real. Every grain of pollen in a sealed core, every fragment of charred bone in a buried hearth, every stone tool lying on a deflated surface where the wind has carried away everything that once surrounded it, is a sentence in a story that is still being read, still being pieced together, still far from finished. You don't need to know how it ends. That's not really the point. The point is that it's still being told by patient people doing careful work in difficult places, and that the Sahara, for all its emptiness, for all its silence, is not empty and is not silent. It is full of evidence, more than anyone has yet been able to gather, let alone interpret. And somewhere in that evidence, in some combination of findings that hasn't been assembled yet, in some core that hasn't been drilled, or some site that hasn't been opened, or some collection that hasn't been reanalyzed with the tools that now exist, the shape of what happened there is waiting to come into focus. Not all at once, not dramatically, but slowly, the way the Sahara itself changed, one season at a time, one generation at a time, until the world looked different, and nobody could remember exactly when it had started.